these are some examples, different examples, and this is the area I think you're gonna struggle with. So I'm gonna give you some more examples. Is if you describe a relation R function by equation in x and y, you can switch the x and y to get the inverse. So here, consider the function f of x equals 2/5 x minus 10. Write the inverse. So it says to replace f of x with y. So you get y equals 2/5 x minus 10. Switch the x and the y, and that's what they did. And then the next step was to solve for y, so they added 10 to both sides. And then they multiplied by the reciprocal, which is 5/2 to both sides. So the inverse is going to be 5/2 times x plus 10. It says graph the function and its inverse on the same graph. So I'm going to go ahead and graph the original function, y equals 2/5 x minus 10. So we know that the y-intercept is -10. Of course, we can't show it there. We do know that we can come up with a table if we wanted to. We have x and we have x and y. And we'll start with 0. 0 is -10. We can't graph that. The next one is going to be 5. 5 times 2 is 10. It's 2, so it's -8. That's not going to work. How about -5? We have -5. Okay, that is -2 is -12. Okay, that's not going to work. I noticed it was not going to work, so I'm going to go ahead and use Desmos. And so if you want to pause it, you can. I'm going to go ahead and pause it and go into Desmos. So here we are in Desmos, and we have f of x equals 2/5 x minus 10, which is the red graph. And then g of x is equal to 5/2, and then we have x plus 10. That's the inverse. Now you notice they're kind of being reflected, and that's the property of an inverse, that it would be reflected over y equals x. And if I were to make a table, and if I made a table for this one, you would notice if I were to put -10.8, you notice you get the inverse. -10.4. We're getting the inverse. If I have -10 here, you get the inverse, -9.6. You get the inverse, and then -9.2. We don't need this. So you notice that it's reflected over y equals x. That is a property of an inverse function. So for these examples that I'm going to give you, I'm going to go slow so you can understand how to find the inverse of a function and its inverse. So instead of having f of x, you're going to write y equals x plus 2. What you're going to do next is you're going to switch the x and the y, so you have x equals y plus 2. And then you're going to solve for y, subtract 2. So now you have y equals x minus 2, and this is the inverse. So you want to use a proper notation, and that's the inverse. So for number 1, we have y equals 2x minus 1/3. So what you're going to have to do is you're going to have to switch the x and the y. So you have x equals 2 minus 1/3. What we're going to do is we're going to apply, we're going to solve for y. This is the inverse. So we're going to add 1/3. So you have x plus 1/3 is equal to 2y. Remember, the blue is representing the inverse. Divided by 2, or you're multiplying times a half. So you have 1/2 x, that's 1/2 times x, plus 1/2 times 1/3 gives you 1/6 equals y. So the inverse of this function is going to be 1/2 x plus 1/6.